Hello, this video is showing you the process of fiber spreading. So right now I'm just spotting 2 microliters of our cell suspension onto the slides. And then we let those dry for about 7 minutes until they're not completely dry, but if we look from the side, they're flat. And then after they are dry, we take 7 microliters of our lysis buffer. So this allows our DNA to interact with the slides. So DNA has a net negative charge, and we use these positively charged slides in order to spread out the fibers. And so I'm just kind of mixing the lysis buffer with the cells and speeding it up a little bit so you can see that. Right, there's our little spots. They're about a centimeter wide. And then now we prop them up to kind of oh, I'm spotting another set to dry while I tilt the other slides. So we do have to work like kind of set by set just because of the timing of everything and the way you have to watch the slides drop. So I start off at a very low angle and just prop them up a little bit. And then I watch and see if our drop is moving. This is sped up 2 times. This is actually a pretty good rate for the drops to be falling. And I just keep my eye on them, make sure they're not moving too slow or too fast. And this is really dependent on the conditions of the room and how much you let things dry. Yeah, very boring, just watching drips down a slide. I'm moving a little bit slow, so I'll adjust the angle a little bit. Even more. And then now you can see that drop kind of sliding a little bit faster. And the goal here is to get the drop to be fully dry by the time that it reaches the bottom. So you can kind of adjust the angles. It's really annoying. And this is the process that you guys are going to be hopefully making a lot easier for us. Now I'm doing the same thing with the other set. Adding the lysis buffer, swirling it around. And then while those are lysing, I'll spot the other cell suspensions onto the next pair of slides. And then this is just kind of showing you, it's hard to see, but you can kind of see that streak down the middle. That's what you're looking for. That's the DNA that has spread against the slide. And so on the left, it moved a little bit faster, so we get a really thin streak. And then on the right, we get a wider pattern, which is what we're looking for. Then go to the next pair, tilting them. And this process is pretty closely timed. We let the cell suspensions dry on for about 7 minutes, and then we lyse the cells for 2.5 minutes, and then I will tilt them after that. So they're all prepared the same way, but each drop behaves very differently, and so that's why we do all of these kind of in pairs, because it's hard with a big group to kind of monitor the rate that all of the drops are sliding down the slides. And so you kind of have to watch them, babysit them, and make sure they're not moving too quick or too slow. So these ones are moving way slower than the first set, so I've increased the angle much earlier. And I have cut out a lot of this process as well. And then sometimes if they don't move enough, I will add another few microliters of the lysis buffer just to make that drop a little bigger and make it heavier so it can spread faster. Increasing the angle again. Then moving on to lysing the third set. So this video is kind of a perfect example of why we need your machine. This process is super inconsistent. We get very different fibers from each to the point where here I have 3 samples and I'm doing 2 slides per sample just because chances are one of them looks terrible. And actually the set I did right before this, I ended up having to do a 3rd set because they looked so terrible. Yeah, this one is just really not moving. So increasing the angle, adding more buffer, and then it just goes all at once. And so this is not ideal. And this is also sped up 2 times, so it's not quite as fast as it looks. And then moving on to tilting the last set. Starting at a very low angle. The drops were moving very fast on this day. And you can see, like, you can't sorry. You have to watch them very closely and make sure they're spreading the way you want. So this is the fibers that we get. We are looking for this kind of branching shape at the top with a wider kind of streak down the middle. So you can see I did all of these very similarly, but they all look very different. So we'll go through and choose which one out of the 2 slides looks the best. And so this one's not very good because the path is very thin. This one looks a lot better, wider. It means the DNA has spread